The second important thing here is permeability. I know we defined these two terms before. However, now we are presenting formula and so on. So permeability can be calculated, or you can calculate permeability if you could know two main things: flow rate and pressure difference. And that what we talked about last time in the well testing lecture, when we said like the in situ permeability can be calculated directly from the reservoir during the well testing if we measure flow rate and pressure. And as you know, in well testing, we are actually measuring these two quantities, the flow rate and pressure, right? So this formula, which comes from what we call Darcy's law. Darcy is a French engineer who was living in the 19th century. In the middle of 19th century, around 1856, I guess, he wrote this simple equation, which after that, or after him, it's represents the core in modeling porous media, as you will see in this course and in other courses if you will continue in the petroleum track. So this considers the core for modeling and many other calculation. So it's kind of the nucleus of our modeling in porous media or reservoir modeling. So from Darcy's law saying what? The flow rate equal the cross-sectional area A multiply constant, which is the permeability, because this permeability, divided by fluid viscosity, and this can be combined with Q. We'll talk about viscosity later on, and after a few slides. Multiply with the rate of change or rate of change of pressure, or we call it pressure gradient. Pressure gradient is very important if we measure pressure in the pore hole and far away from it, let's say at the reservoir, somewhere in the reservoir. So it's very easy to calculate the rate of change, just the difference of pressure at two different points divided by the distance. All right. And so the formula of the permeability is kind of algebraic formula. So permeability equal flow rate multiplied with distance divided by the cross section of the pipe, or whatever was, if you are measuring it in well, or measuring in a normal porous media. So it's kind of cross section area. And here is the difference of pressure. Be careful here. We have it's better to put two parentheses here, because this is the pressure difference. All right. Yes. The permeability of the reservoir depends on the size of the grain, and the size of the grain of the porous media cell, the formation. So if we have large grains, we'll have high permeability. If you have small grain, low permeability. In practical application, physically, or using the SI unit is meter square. However, in the Society of Petroleum Engineers, we use usually millidarcy or darcy. And one more feature about the permeability is generally is anisotropic. What does it mean? Anisotropic means it depends on the direction.